Thank you very much, Derek. So my name is Ed Davies. I'm one of the lead developers of the JUCE framework. And the talk this evening, or in the morning, wherever you're based, is going to be talking about how we're adding accessibility features to JUCE. So since this is only a 25-minute talk and it's pretty dense, I'm going to blast through the information here, and there may or may not be time for questions at the end, but if there is, I'll get to them. If not, there's a slide at the end of the presentation which has all my contact information, Discord handle. You can also just find me. I'll be on Remo during the conference. So yeah, feel free to just shoot me any questions you may have asynchronously. So this talk is going to cover 4 main topics, really. So first of all, we're going to talk about what exactly accessible software is, just give a brief introduction. And then we're going to give an overview of the native accessibility APIs that are provided on the by both Apple and Microsoft. Then we're going to lay out some of the unique challenges that JUCE faces implementing these APIs. And then we're going to discuss how exactly we're overcoming these to provide accessibility support as one of the next major features in JUCE. So at its core, accessibility is really all about enabling users with disabilities to seamlessly use your software in a way that doesn't involve changing their existing workflow that they're already comfortable with. So most major operating systems have pretty comprehensive built-in accessibility support that we can leverage here. So we don't want to be reinventing the wheel, really. And these accessibility clients in the operating systems will allow users to navigate using just the keyboard. They give audible feedback to help the user navigate, read out control UI properties, and interact with UI elements. So this is on macOS, the VoiceOver utility, and on Windows it's called Narrator. And in order to leverage these in our software, we need to expose some information about our app to these clients. So the real kind of bare bones stuff that we need to tell the accessibility clients about are things like names and descriptions for all our UI controls. We need to provide some sort of programmatic access to our UI elements and text. We need to have full UI keyboard navigation. We need to build up this hierarchical model of our UI that represents all our UI elements and that the accessibility clients can use for navigation. We need some way of indicating the current keyboard focus and managing that. And it also is bidirectional. So we need some way of notifying the clients when things within our app change that they may not be aware of. So that's things like keyboard focus changing, opening and closing of windows, control value changes, and so on. So apps built using the native toolkits, native UI toolkits on operating systems typically get this kind of support for free. But with JUCE, it's really a little bit trickier. And that's kind of what this talk is going to be about. So in order to understand why it's trickier, let's sort of pick apart and discuss the anatomy of a typical simple JUCE application. So if we take the Hello World demo example from the JUCE repository, this is just a simple single window app that draws some background in our window. So a nice speech bubble and a sky blue painted background. And it has a label displaying Hello World and just a text button in the bottom right-hand corner for allowing the user to quit the application. So at the top level here, we've got JUCE's application base class. So this really is just handles all the kind of application basic housekeeping stuff. So startup and shutdown, manages the event loop, and just sort of general housekeeping chores. And then if we drill down a bit further, we get to the JUCE component peer class, which is kind of one of the really important classes that we're going to talk about. And we'll talk about it in more detail later. But to give a real brief overview here, the component peer class creates and manages the native operating system window. And it contains the root JUCE component of our UI tree. And JUCE components, if you're not familiar, are just the base class for all JUCE UI elements. And the component peer, as well as creating and managing the native OS window means that it kind of pipes the mouse, keyboard, and focus events to and from the operating system as well. So it's sort of the entry point to the OS. Going down a bit further, we've got a top-level window class. This is just a JUCE component that has some special tasks like managing lists of other top-level app windows if it's a multi-window app, handles the active window status, and things like drop shadow and stuff. And it is our root component in this subtree of JUCE components. Going down further, here we've got our MainComponent class, which in this case is painting our background. So it's painting it blue and drawing our speech bubble path for us. And then as children of this MainComponent, we've got a label, which is saying, just displaying our hello world text. And we have a text button at the bottom right. And that's pretty much it for this example. So it's just a real simple JUCE app with a few components. But if we look at how an operating system sees this, so for example, how macOS will see this. At the top level, we've got the NSApplication, which corresponds to our JUCE application class. And then we've got an NS window, which handles things like the native title bar, resizing, minimize, maximize buttons, and so on. And then below that, we've got the NS view class. And then it kind of stops as far as the OS is concerned. And that's as far as the OS can see. So why is that? And the reason is because of the component peer class that we mentioned earlier. So component peer manages the native window, which on Windows could be an hwind, so window handle. macOS, it'll be an NS view. X11, it'll be a window class. And all of the actual JUCE components, and so our main component that does all the background painting and all of our button and our label, they're rendered within the context of that peer, and they're not backed by any native UI elements. So the operating system has no idea that they exist. And the reason that we do this in JUCE is because it has some benefits in that we get consistent rendering and UI behavior across all platforms. So JUCE being a cross-platform framework, that's really important. So if you build a JUCE app on macOS, it's going to look the same as it will look on Windows, as it will look on Android, iOS, Linux, and so on. And that's one of the real benefits of JUCE. And it also means that there's less code required when we need to support new platforms or windowing systems, because we don't have to re-implement every single JUCE widget in native code. All we need to do is draw to the native window and implement the drawing primitives in order to draw our components. So this, unfortunately, means that the OS and any accessibility clients in the OS only really see the top-level peer, and we need to inform them about the rest of the UI. And we do this by interfacing with the native accessibility APIs that are provided on the platforms. So then we can actually tell it about our UI, and it can have some idea for navigation and so on, and presenting that to the user. So we're going to now talk about these native APIs and go into a bit more detail about what they contain. So first of all, we're going to talk about the Apple API. So this is implemented via the NS Accessibility Protocol on Apple. And this is an Objective-C protocol. So just as a quick sidebar, protocols in Objective-C just declare some methods and properties which are independent of any specific class. And classes can then just conform to one of these protocols. And if a class conforms to a protocol, it's just indicating that the class will respond to the required methods in the protocol and can optionally respond to those that are marked as optional. So any accessible UI elements on macOS need to adopt this protocol. And many, if not all of the AppKit controls, so all the standard UI widgets on macOS, adopt the NS Accessibility Base protocol and provide default implementations for all of its properties and all of its methods. So this is things like NS View, NS Button, NS Slider, and so on. But any custom controls can then adopt, instead of adopting the full base protocol, which is quite large, can adopt a subset of this protocol that is specified for its role. So there's protocols like NS accessibility button, slider, group, and so on. And they're much shorter. So if we take the NS accessibility slider protocol, for example, this is the entire protocol. So any custom slider, and when I say custom slider, I mean a slider that isn't derived from NS slider, because if it derives from NS slider, it would already have default implementations for all of the basic protocols. So anything that is just a view-backed UI element and wants to behave as a slider to an accessibility client would just adopt this protocol. So accessibility label property is just the title of the element, has a value for the slider, and a couple of selectors for performing increment and decrement on the slider value. However, this assumes that the custom control is backed by an NS view. So that's either going to be a direct NS view subclass or a subclass of any AppKit control, because they subclass themselves from NS view. So NS view is the base class for pretty much all the AppKit UI elements. And it just sort of takes care of basic housekeeping tasks like managing the UI view bounds, parent-child relationships, painting and rendering, and so on. But JUCE controls, as we said before, are not backed by any kind of NS view. So any JUCE controls will need to subclass this NS accessibility element class instead. So this is the declaration for NS accessibility element. It's an interface, not a protocol, so it's an actual class that we can subclass. And it manages the basic infrastructure that's required to interact with an accessibility client. So it's going to represent any control that isn't backed by an NS view in the accessibility hierarchy. So in order to have one of these, we need to subclass it, we need to adopt a role, and then we just need to add it to the root NS view via the NS view's accessibility children property, so it's correctly represented in the hierarchy. And then we can just freely adopt any of the NS accessibility base protocol properties and methods that are required for our control. So if we look at how, for example, the Hello World demo will be represented, you can see here we're taking our label and our text button, and at the top here, we've got the role that we've adopted. So a label is taking on the NS accessibility static text role because it's just some static text that isn't editable, and it's adopting the parent, frame, title, and value properties, so providing values for those. And our button is basically doing the same thing. It's taking on the NS accessibility button role and implementing the same properties as static text, but with a few more for managing things like keyboard focus. So is accessibility focused, set accessibility focused selector, and also has a selector for performing a press action. So if the user wants to programmatically perform essentially a mouse click on the button, we can use that selector. And we also need some way of notifying accessibility clients of changes within our app. So there's the NS accessibility post notification method, which will send a notification to any observing assistive applications. So that could be screen readers. And this doesn't go via the standard NS notification center method because there's a little bit more going on behind the scenes. But you can post notifications for things like UI elements being created, focus change, windows created, value changed, and so on. And you also pass in an ID of the accessibility element that it represents and that it applies to. And that's really it for the Apple API. That kind of covers most of the important points. So now we'll look at what the corresponding API is on Windows. So on Windows, accessibility is implemented via the UI automation framework, which is just shortened to UIA. This contains accessibility code, but it's also more broadly used for programmatic UI control in general. So this is for things like scripting, it handles GUI unit testing, and so on. But there is a core accessibility lib within UIA that we need to implement. It's a COM interface, and it's supported by the standard Win32 and XAML controls. So if you use those, you get this for free. But like we say, JUCE doesn't use them, so we need to actually dig into the code and implement some of the framework. So there are three important interfaces really in UAA that we need to talk about. The first of which is the raw element provider simple interface. And as the name suggests, this is the interface for just really simple UI elements. And this handles things like a connection to the host windows, so the host hwind that the UI control is contained within, control pattern type, and also managing control properties, which we'll get onto a bit later. The second class or interface that we need to talk about is the provider fragment interface. And this is for slightly more complex UI elements. So UI elements that are part of a structure that's more than a single level deep. So anything that's within a UI tree or is contained in a subtree of UI elements. So that's going to be pretty much all UIs. So even our very simple Hello World example had a tree that was 3 UI elements deep. So we need to be implementing the fragment. And the provider fragment root interface is representing UI elements, which are the root of this structure. So the very top level component, which in our JUCE case would be our top level window. And this has methods for fragment retrieval, so getting the focus fragment, getting fragments at specific mouse position, and so on. And what it looks like in kind of a very simplified form is at the top level, we have our hwind, which is our Windows window handle. And this will receive a WM get object Windows message. And in response to that message, needs to return the fragment root of its UI that is contained within the hwind. And then any navigation is sort of drilled down from the fragment root. So you can see below our fragment root, we just have a couple of fragments, which may be any UI elements, but in our case will be our label or our text button. And any customization of these providers is done via control patterns and control properties, which we'll talk about now. So control patterns are analogous to the NSAccessibility methods that we talked about earlier. And they enable an accessibility client to manipulate and query information on a control type. And providers need to subclass these interfaces and implement control patterns for specific control types. So for example, there's the window provider, which represents just a top level window. There's the invoke provider, which represents an element that can be invoked. So for example, our text button would be an invoke provider, and that has an invoke method, which will be called when, for example, a press is performed by the user, text provider, and so on. And these are returned via the raw element provider simple get pattern provider method, which is just going to return an unknown pointer to one of these subclasses that you need to implement. And control properties are what enable an accessibility client to retrieve information about a control. So information such as the control name, the control type, its bounds, and so on. And the provider simple interface has a get property value method, which is called with one of these property IDs that are listed there. There are multiple. We won't go into them all here, but there are just a few examples there. And this needs to return a valid value if the property is supported by the control. So there are some required properties, but most are optional. And also they are context dependent. So these are really analogous to the NSAccessibility properties that we talked about earlier. So if we then look at how our Hello World demo looks in Windows land, you can see we've got the role at the top there, so text control type for the label, the button control type ID for the button. Then we have some control patterns that each of these UI elements support. So the text control type just supports the value pattern because the value would just be its text, whereas the button supports both value and invoke. And then we have some property IDs, so name and keyboard focusable for the button, and just some methods as well that are useful here. So navigation between siblings and parents and children, the bounding rectangle, and also for setting focus for the text button. And for notifying of events within our app, there's the UIA raise automation event method, which is very similar to the macOS equivalent and it just notifies any of the subscribed listeners of some event has taken place. So again, we've got things for focus change, windows opening and closing, property change, text change, and so on. And that kind of summarizes the Windows side of things. So now we're going to take a look at how we're actually going to implement these APIs in JUCE. So what we really need is a unified API for exposing the required information and the required programmatic control access for JUCE UI elements. And we want this to support all the standard JUCE widgets by default. So things like JUCE button, JUCE text editor, JUCE slider need to be built into the library. But we also want it to be extensible and customizable for supporting custom JUCE components. So for example, if you have a really cool XY pad that's used for your parameter control in your plugin, for example, then we want to have the API be flexible enough for you to be able to implement your own accessibility handling code to provide sensible and useful accessibility control for users. We also need an API for posting custom and required accessibility client notifications, so notifying screen readers and accessibility clients that things have changed within your app. Luckily, JUCE already contains a lot of the required functionality and has a lot of helper classes for doing things like this. So JUCE component already contains some fairly sophisticated tree navigation methods. There's methods for converting between JUCE and native screen bounds, which can be quite tricky. So that's things like the flipped y-axis macOS coordinate system, and for dealing with high DPI coordinates on Windows screens. There are methods for UI programmatic control. So, for example, the trigger click method in button. There's some good classes for keyboard focus traversal and managing keyboard focus within JUCE apps. And JUCE component itself has some useful methods for querying and changing states. So things like focus, enablement, visibility, and so on. So we really need to bridge the JUCE code and the native libraries. And again, JUCE has some helpful tools for doing this bridging. So as we said, NS accessibility is an Objective-C AppKit framework. So we need to be interfacing with Objective-C from JUCE, which is C++. And JUCE has a really useful Objective-C++ wrapper class, which means we can just wrap arbitrary Objective-C classes in a C++ interface and use them. So that's really helpful here. And UI automation is a Win32 COM interface. And JUCE has tons of helpful classes for dealing with the joys of COM code. So things like the COM base class helper, which handles ref counting, query interface with multiple inheritance, and so on. And the UIA code is implemented in UI Automation Core DLL. So we need some way of also loading that DLL and pulling out the required symbols when requested by a client, and also when it's supported by the OS, because it may be that the DLL isn't present on the system, so we need some sensible fallback code in that case. And so the API is still kind of in flux at the moment, but broadly what it looks like is the JUCE accessibility handler class. And this has some things like platform independent roles. So this is just an enum class with some roles that aren't specific to either platform, but will be broad enough to cover both. Support properties, so things like name, help text, description, state, so focused, whether it's selected, ignored, modal, and so on. Getting and setting control values with both support for text and numerical values. Support for programmatic UI actions, so things like pressing, focus gain, selection, and so on. Full navigable text support. So this is support for insertion, deletion, selection, character, word, and line traversal, getting text bounds, getting text offsets at points. All of these are required for the OS's text traversal methods. And also table and cell support, so navigation between cells, rows, and columns. And this needs to have the native implementation all nicely packaged and hidden away under the hood, so the user is never really interacting with the native APIs. And just very simply looks like this. So we've got our JUCE accessibility handler at the top, which covers both the NS accessibility element via the NS accessibility protocol and the raw element provider classes via UI automation. And this drips down to VoiceOver on macOS and Narrator on Windows. And this is what we currently support, but in the future, there's quite a lot of scope for some further work. And hopefully we can extend this class, and it'll be designed such that we can extend it to cover this further work. So this is things like mobile platform support, Linux support. We also want some way of providing direct access to the screen reader, so you can just post text to notifications, native menu bar support on Windows 10, desktop push notification support, haptic support on mobile, which is very important for accessibility, perhaps direct access to system color settings, so things like high contrast and inversion, and also implementing things like native scroll behavior. So all of these would be nice to have for providing full accessibility support in JUCE. And that really covers it. So I'm not sure if we have much time for questions, but like I said, you can always reach me on the JUCE forum. I'm there, I'm ed95. This is my email, just ed@juice.com. I'll be on Discord, and I'll also be in the JUCE Q&A, which is tomorrow at 2010 UTC in CHUCE, where you can harangue me with JUCE bugs and feature requests. So I look forward to that. So thank you very much. We've got Brett asking, when is this going to be JUCE 7 era? And what can you do now to prepare your code for this? So this is not going to be JUCE 7, this is going to be part of JUCE 6. And when is soon TM. Hopefully very soon. But yeah. And in terms of preparing code for this, I mean, there shouldn't be too much. If you're just using stock JUCE components, then you won't need to do anything, unless you want some sort of custom focus traversal behavior, which will provide methods for doing, but that will be the only thing that you need to implement. But like I said, if you've got any particularly complex custom UI elements, then you might need to think a little bit about how you want those to be accessible. But the goal is to provide an interface that's extensible enough for you to do that. And then we've got another question saying, do you have to do any specific work to get the accessibility handler to be properly associated with views? I'm not sure if you mean kind of NS views in this sense, or just more general views. But I'm going to go and assume you mean just views in general, as in kind of components. And no, it should be, like I said, it should be really simple. If you've got custom JUCE components, we're going to provide an interface for you to be able to provide your own derived accessibility handler to perform the behaviors and customized behaviors that you want. But if you're just using stock JUCE components, then the idea is you'll just get all this for free. And then we've got another question saying, are there any of the UI libraries you know of that have accomplished cross-platform accessibility in the manner you're working towards? Yes, so I know that Qt has really extensive accessibility support. And I'm not too sure. I mean, a lot of the other kind of cross-platform UI libraries are using native UIs under the hood, so they get this sort of stuff for free. But yeah, Qt is a good example, I think. Chromium as well has some interesting stuff for their kind of desktop UI accessibility. Any plans for supporting large text size settings? Yeah, I mean, if we can provide access to the system accessibility settings in a nice cross-platform way, then that's going to be kind of part of the further work that I mentioned. And supporting large text size settings, for example, I guess on mobile platforms, having that be something you can control programmatically would be included in that as well. So yeah, that's kind of part of the further work, really.